Yeah, so I want to set the stage a bit and tell you a bit about John Deere and what we do. I don't know how much you're into the agricultural space. So I want to introduce, first of all, our customer to you. So this is obviously a guy that feels very much connected to the land. So they love to be outside. They love to be in the land. And you recognized in the title, it's about mobile. So obviously with mobile devices today, that's a great opportunity to get something into their hand that can really help them while they are outside there. So this is the very basic motivation about leveraging mobile in this domain. So what does John Deere do? So we come from producing agricultural machinery for many years. So that's tractors, combines, sprayers, all these machines. But what it more and more takes to be successful in that domain is not only build great machines, but putting software and services all around that. So that's similar to the automotive domain. So there's also more and more growing an ecosystem around these machines, and that's also the case for us. So these machines are very sophisticated. So based on high precision GPS, they are driving almost autonomously in the field, or they are driving autonomously if you have the right equipment. The operator is most of the time only sitting there for legal reasons. Yeah? So what has happened in the last years? So obviously these machines, they produce a lot of data. So inside the machine, you want to know exactly what goes on. So we are collecting a lot of data to improve actually the machinery, but also our customers can benefit a lot, because with that machines you can basically document what happens on each centimeter of the field outside. So if you apply a certain seeds, spray, bring out fertilizer, collect all this data, at the end of the year you harvest, you collect all this data and bring it together, you can learn enormous knowledge. So that's how all this ecosystem grows. The machine data is the basis, but you can leverage it a lot and make a lot of new services for our customers out of it to make them more successful. So obviously there is something, it's called My John Deere, that's our cloud. There we collect all the data from the machine. They come in via telematics gateways. There is a web portal that was the first services for customers, so you can see what's going on the field, and they can start analyzing things. But what now, obviously comes up is the mobile devices. So we see a great potential in leveraging these mobile devices, because I said these guys want to be outside, and based on all this data, they want to get decision support right when they are out on the field. So it's a very dynamic business. So weather changes and certain products you bring out on the field, they are very sensitive regarding the weather conditions. So you really want to know, what is the weather forecast, what has changed. You want to be informed about your machines and the status, and machines that maybe broke down. You maybe get new jobs in, and you want to reschedule your workload. So a lot of potential in using these mobile devices. So that's what now really started the last years. We imagine this to be a big ecosystem, a big mobile ecosystem inside this, and we expect this to be really a first-class product of John Deere. And that's what we will talk about today, because when this came up, we said we want to architect this the right way. So, and that's why we started a collaboration with Fraunhofer IESE in Kaiserslautern. So we are co-located. I'm from a German office of John Deere. So we started this there, and it's about how we integrate now these mobile devices into this overall ecosystem. You see there's also an arrow to the machine directly. That's not that much in scope today, but that's also an interesting topic, to be out in the field and directly make a connection to the machine via Wi-Fi, Bluetooth, or whatever, directly get CAN data. But that's really safety critical. So we are not yet there that we can really have this in production. Okay, so we started a project, and these are some of the very basic questions we had and we want to solve with our architecture work. So, yeah, one versus many apps. So there are so many use cases in our heads. So how do we structure all this? How many apps will come out of this? And how do we produce all these apps over time in an efficient way? Native versus hybrid versus web applications, especially in the beginning, was a big discussion. Online versus offline, yeah, that's a hot topic, and you find this term also in our title, because our machines, they operate in rural areas, so there is often a bad connectivity or even no connectivity, and this will not change. So it's not a business case for large telecommunication providers to set up networks in these areas. So this will more or less never happen, they tell us. So we have to really take care how can users use our mobile devices and apps in these conditions outside. If they don't work well with these conditions, they will never be the tool a farmer uses on a daily basis. So with that, we started in a project. It lasts already since end of 2013. So this started to be a very successful setting. So we have a lot of people in there. We extended the scope several times. And we basically do the UX design of the apps besides the architecture, but the architecture and prototypically implementing this is really core of our collaboration. And we have our prototypes in testing environment with real customers. And the interesting setting is, so this is kind of our prototype app ecosystem. We run this in parallel to our production apps that started a bit later, and we are continuously feeding the results of our research, the architectural concepts that have proven to be successful in the production version. And that makes all this collaboration very successful, and it's a very interesting setting to run these two in parallel. The first one is our playground. That's where we mainly talk about today. And the other one is really what then goes in production. There are some constraints that, there are harder constraints there. But in this environment, we really can try things out. And Matthias will now tell you a lot more about the technical details of our work. So, Matthias.
Okay. Do I also work technically? Great. Okay, what did we look at now in the preparation of this presentation? You also saw it in the title, it's data. We could talk about many different things, but today we talk about data. And the reason is the following. When we look at typical architecture documents, and we also recognize this in our work at some point in time during the project, data is really underrepresented. Also in this conference, I sometimes have this feeling data is a bit underrepresented. Simon talked a lot this morning about the structure and components, connectors, all that stuff, and he had a little slice on data, but he didn't say any word on that. And we do the opposite now. We talk more or less only about data. And so let's look where this leads us. Yeah. So when we typically look at data, then you see, we have this layered architecture. Here it is again. Yeah. Simon said, this is more or less out, but here it is. Often we find it. And where is the data? The data is actually here in the data layer. Do you see any more data in architecture documentation? Sometimes you have a domain model, but not much more. There is the data. And where's the data really? The data is more or less everywhere. Yeah, it's in all the layers because the data has to come from the database to the UI. The database has to be transformed on these connectors here. The database has to go to the context because there are typically other systems. Everywhere is the data because the systems communicate about data. So why don't we care about it? Yeah. So this was our observation too, and so we wrote a Wixer paper and have this presentation here at SATURN. And so let's have a look at that. Yeah. So what does this mean for architecting? Yeah. So I have now a two-stream presentation. One stream is that I really talk about this ecosystem as Ralf introduced it. And the other thing is that I strongly talk about data and the role of data in that ecosystem. And we tell a story from a very small app to how this ecosystem has grown. Please note, this is not exactly the order in which we constructed it. This is the story now in which we can tell it right. And this brings me to Jochen from this morning. and his presentation. So we thought what would be the right style to present this here. And so you will hopefully see several things that we adopted up front from yourself. So first thing that we can have a look at is on the next slide with some colors and not the diagrams from the tool. So they are not complete. They are not always that sound. They are not generated from the repository, but I hope they fit our purpose here. So let's start very simple. Here we have an app. There's one app. We want to build this. It's on the iPad because we want to go mobile. And now what's the architecture? Also in terms of data. So let's look inside. Very standard 3 layers architecture. Also, this is exactly what you can find prescribed by Apple for iOS. And you can say, you have a clear MVC pattern, you have a UI, and the data is basically in core data and in your SQLite database. So this is very simple, and they say this is the way how you should do it. They provide you code fragments. You can do it exactly like that. That's the point how we did it. Okay. And then you have this data modeling. This is also in the Xcode environment, and you can directly generate your core data structures and put this into SQLite. Let's make it a bit more difficult. And you see now there, the headline is always our architectural challenge, and I will present you what is the outcome and what have been the architectural decisions that we made on the way to there. So next thing that we have, so we are multiple users working on the same data, because on a farm there's not only the farmer, but the typical farm has a lot of people working there. And so it's kind of an enterprise resource planning system, for example. And there's a lot of data, and that has to be integrated. And now we have different people, and they are using their devices, and this data has to be shared. How do we do this? So integrating between these apps. So let's have a look. Different apps on different devices. It's hard to communicate there. Maybe you could have a direct communication if they stand beside each other, but that's typically not the way how this is happening. So that means we are communicating via a cloud backend. So we develop this backend. Here you see we have more layers here, and the yellow stuff here that you see is always what we introduce now in that specific step with respect to data. Here's a strong relationship to data. Here we introduced Hibernate as an ORM, and we have a MySQL database, and we exchange our data via this backend. Okay, let's have the next step. So we have apps, more than one app. Ralf introduced this challenge, and we discussed long about that. Do we have one app on a device that does everything, or do we have multiple apps that have a specialized task? And we said, it's the more natural way. We have multiple apps. Next problem we have with data, at least for iOS, we have the problem that if those apps want to share data, iOS somehow prohibits this. It's not allowed, at least until iOS 7. But when we worked on this, there was still iOS 7, and now we just have iOS 8, but we still didn't change that. So that means how does this communication go? If it's not possible, actually there is no way to share this data. You can share a link or so, that is possible, but if you're talking about enterprise data, you cannot share that. We have simply this restriction. So the way that we went here is we also share this data via our backend. So that means, again, we use the stack that we built up so far, and whenever someone changes something, this is written in the backend, and if you change the app, it has to be reloaded, and in the other app, it has to be integrated, so we have kind of a synchronization there between the apps. Okay. Now comes the big thing that also is in the title and that Ralf introduced. We also decided we have to do this for offline, because the key user experience for these apps is only if the farmers can really use it all the time. Because otherwise they say, there's no internet, so I cannot do anything. That was not acceptable, so we had to invest here. So if connection is broken, our apps still should work. And this makes it really difficult now. So we thought about, there might be a technical framework. There is a technical framework for everything, and we looked into database providers, so there are things by Oracle, There are things by Couchbase, and there are many other things. But in the end, it turned out the risk was too high to adopt this because we always had the feeling that we will not reach our goal with this high user experience. Technically, there would be a synchronization, but we thought we might not get there where we want to. So that meant our decision was we built this on our own. And this was probably the worst estimation in terms of effort that we had, how much it would cost to build this here. Yeah, so this was really, really expensive. And I'm talking only a little bit what we all had to build here. So we, besides our data services, now we also introduced quite heavyweight sync service with which you can sync all this data. And for that, we needed then a sync engine on the client side, and they had to be well integrated. The data had to come from the backend database via the sync service to the sync engine, and then to the core data and to the SQLite database. And this all in a non-obtrusive way, so that the user still has a high user experience. But nevertheless, we have a good data consistency and not too much conflicts, and we can work smoothly. So this is really difficult. And what we introduced here are some concepts in terms of additional metadata. So we had to get an additional ID. So we used UUIDs for every single object in the system. And then we had to introduce a revision ID so that for every object on every device, we know when we come back to the back end whether this is still in sync or not. And then we have a sync state for every object where we say we updated this on the client or whether it has been deleted and so on. And we had to come up with conflict detection, conflict resolution, all these things. This is all a lot about data. All these yellow boxes here have been highly affected by that. And if you simply draw them in architecture diagram, you wouldn't see anything about that. Yeah? So we have a strong connection to the data topic here. So then we found out, and this was something that we also found out later, which great importance it has, data has different characteristics. Somehow this is of course clear, but how much it should influence your data modeling and your architecture was not so clear to us in the beginning. And so you have here some typically data items. Yeah, so this is the abstracted domain model now. We have fields, machines, persons, jobs, assignments, and so on. And then we classified them also according to some standard classification. So this is more the master data stuff. And then we have more transactional data. And then we have now, according to domain-driven design, more the entities here and more the value objects. So all these well-known design principles. But the question is, how do you really use that? And they change with different frequency. So transactional data comes up and changes very much more frequently. And so we use this to come up with rules for our data modeling. Yeah? Next thing was, John Deere wants to operate more customers or all customers on one backend. Yeah, this saves a lot of money, of course, if we have a multi-tenancy system. But now all the data is in the same system. Yeah, and this has to be handled somehow. So all these tenants, one backend, and now you have all this tenant data, and you have to separate this somehow. And this means we also introduced another attribute here. So the tenant ID for every single object, and according to that, the data was selected when a request comes for synchronization. Yeah, and what becomes also interesting here is now that John Deere also provides own data, so which doesn't belong to tenants. So you also have to mix this data. Yeah, so there's the data that belongs to John Deere and to a specific tenant, and that has to be mixed when it goes to the client. Next challenge. Then another big thing, multiple users share one device. Yeah, so farm, someone works in the morning, someone works in the afternoon, one device, but this is actually not covered by Apple because there is not a concept for it. So we had to introduce this as well. So we had to come up with login mechanisms. We had to change the UI. You have data there. And the interesting thing is we wanted to keep the data on this device. So that means you have to somehow get the data from the database away and put it somewhere when another person logs in. And another challenge was we have multiple apps on that device, and we want to have a single sign-on. Now they are also disconnected, and there's a concept like this keychain group access, and we use this for our single sign-on tokens, and so we could realize really single sign-on and play around with the data in the background, so that always the right data was there. Next thing now is connecting our system to the world. So this is our system boundaries and where the data goes on there. Yeah? So we have our system now, and there's a lot of stuff that is connected to the outer world. First is we use map services, yeah, because we want to show where are the machines, where are the people, where are our fields, and there we have streaming of data directly into the mobile device from a map service that you can use from Apple or from Google. Yeah, goes directly into the device, nothing via the backend. Then we have integration with other farm management software, because the farmer might have another system and he wants to integrate the master data in that system. So we need import functionality. Then we have weather service. So we work a lot with weather, and the weather comes from the outside, and now we can aggregate in a multi-tenancy system the weather. So that means we have to transform in our own model. We have weather data in our system, and this is aggregated because we have to pay for every single request of weather. And now, of course, we want to aggregate it in the way that if two farmers have fields besides each other, of course, we don't have to pay twice. So we can also make use of this data here. Yeah? Then we have machine identification via iBeacons. So this is, again, connected to the device. And we have this machine data that Ralf introduced. So we can have a connection to the CAN bus of the system and get real-time data from there and feed it also over the machine into the backend. Then we were confronted with an increasing amount of data. Yeah, so when our system grew and we had it longer in there and we had bigger customers, we had more data. So more than 10,000 objects to be synchronized, continuously growing, and we require still this offline synchronization, and this led us to the problem that our initial sync, so when we first log into the system, took really long time, more than 60 seconds, partially even way longer. And so we came up with some data strategies like filtering out old data, compressing here on the connector, then a very special thing, we pre-filled this SQLite database and then put it completely over the wire. And so this was a very complicated strategy to make this happen. Yeah? And in the end, we found out that we had some problems also with our core database, and it needs there, although in the beginning it seemed so simple, it needs a lot of deep knowledge about the technology to make it really fast. Yeah? So just using it is quite simple, but making it fast is really hard. Then we had an increasing frequency of changes of data. Yeah? So we have now fleets with different machines in a logistic chain. Everyone has a mobile device in it. Yeah? And we have near real-time data. And it becomes directly clear that our synchronization mechanism cannot work for that. It's way too heavyweight. And then we came up with a completely different approach here. And we used the CQRS architectural style. And we built this completely besides these other things here. And we have a Cassandra database in here for very fast writes. We have an in-memory database here for high-frequency reads and event sourcing mechanism. So that means every time someone requests data here, it's completely pre-processed here in memory. And the server just says, here it is, here it is, here it is. And whenever it comes in, it's pre-processed over here and directly put in here. So this was another strong improvement. Then we had the challenge to upgrade apps. So this is not completely needed now for the prototype, but we thought a bit about it because now you also have a data challenge. Yeah? So you have different data models because they evolve, and you cannot force app users at a certain point in time to upgrade. For a web backend, you might be able to do that, but not for apps. So we have to do this also in our backend. So we have to have services for these different data models, and we have to aggregate them in the end to one data model in the database to be consistent and to allow the interaction between users of different versions. Yeah? Then the next thing, we had multiple languages to be supported. This is also quite common thing. Yeah, you have English and you have German and all the other things. And the first thing that comes in your mind, yeah, we need language resources for the UI. Seems very simple. You can do this. Of course, no problem. Technically supported. But now begins the problem. You also have to support translated master data, reference data, transactional data, and in particular, metrics and units. And Deere is serving the American market and the European market and others, and they have different metric systems. And they have to be somehow converted. And we found nearly nothing that supports this scientifically how to do that. And we also didn't come up with a perfect solution until now. This is really, really difficult because in particular now as we have this multi-tenancy system, we want to learn over all the tenants. And the question is, in which metrics do you put the data and where do you convert it actually? So this is a really hard problem. And I do not see a perfect solution for that so far. We have to spend more on here. So if we summarize that and look at all these data representations that look so simple, we have now our system here. And these are all different data representations of same or a bit different data. Yeah, we have core data objects, relational tables in the client, and we have JSON DTOs at the connector. We have Java DTOs coming in here, then map to Java entities going down to relational tables here. And for this other type of data, as I said, here we have Java objects in memory, and we have Cassandra column families. These are all different technical representations or physical data models of data. Typically, you never see them in architecture documentation. And we want to make you aware of that this might be necessary to talk about it. And this brings me also to the conclusion with some lessons learned that we would like to share with you in different categories. And the first one is here on quality attributes. Of course, we talk a lot about architecture, is a lot about achieving quality attributes. And first one, and probably most prominent, is user experience and performance. That means to have the right data at the right point in time, at the right place in your overall system. And you have to make sure that this works. And given all these things that I sketched here, you can imagine this is not a really simple task. Coming now to security, which I didn't talk at all about, makes it even more complicated. Yeah, because now you have to filter out certain things that certain persons are not allowed to see. And then, if we come up with all these different aspects that we introduce, maintainability becomes really a hard challenge. Because having all these data models and keeping them consistent and having the transformations between them, of course, strongly negatively impacts maintainability. Then we have some technical aspects. I already introduced that. Offline capability normally doesn't come out of the box. You cannot buy this. Yeah, you have to invest a lot to make this happen. And investing a lot, it was really, really costly to get up with a good solution for that. And for core data and other technical frameworks, you need really good expertise to make this happen. Last one, lesson learned on data modeling. So there is not this single data model. Often we see one data model and this is it. No, typically it's not in a realistic system. Data model is highly intertwined with architecture design. So there is not simply data modeling done by business, but you strongly have to intertwine it with the architecture and the analysis. And just doing it as you learn it in university in object orientation courses doesn't help really. Yeah? So you have to invest more, you have to understand the consequences and the impacts on your architecture and on your quality attributes. That's basically it. Some key takeaways, just briefly summarized. We often neglect architecture, which we shouldn't do, because it's so relevant for the quality attributes. Yeah, you should really think about it and document it. And you saw there's a lot of cool IT in farming, and this is also what we would like to transport to you here. Thank you very much.
Thank you much.